And welcome everybody to the Daily Space Weather Smash Show here, coming at you from the Smash News Network, least busted name in news. Just bringing you the most detailed imagery of the sun and comprehensive space weather imagery you'll find anywhere in the known universe. We may even be live streaming from the galactic core. Sorry folks, our location is classified. And we've got a massive filament fest going on. A massive filament fest indeed. So the likelihood of Earth-directed coronal mass ejections remains at nearly 100%. Also, likelihood of large solar flares very high. Let's go around the horn here and take a look at some of these filaments. We've been naming them on Twitter. If you want to know what they're named, follow us on Twitter at Smashomash. We're all over the internet to enrich your online experience with a bunch of facts about space weather, cosmology, astrophysics, meteorology, and more. Huge filaments showing up there in the southwest as well. How about the southeast? A surplus of filaments over here as well. And what about the northeast? Also, lots and lots of filaments. Next, looking at sunspots, we've got at least one new named sunspot group. This group right up here just spontaneously formed since yesterday. Right there by my pointer. And there's another group just rose up here to its north. You may see that popping out in the magnetogram. It's right on the edge right now, but earlier this morning, I indeed could see umbre there. So we may have two new named sunspot groups today, at least one named sunspot group. And that new one that formed is significant. That's our colorized magnetogram. We like to show it just before we talk about volcanoes. So we try to be self-aware on the channel and not be completely spaced out. Here's some information about what's going on planet Earth. Etna continues to erupt with a lava flow from the southern base of the southeast crater. Not sure if it has stopped erupting yet. Don't pole vault the caldera. Sakurajima, flight level 070. It's producing a 7,000-foot ash plume. Luatolo producing a 6,000-foot ash plume as it explodes. Villarica emitting ash there in that photo. Semeru, flight level 140. It's a 14,000-foot ash plume. 21,000-foot ash plume over central Mexico as Popocatépetl explodes. And now Santiaguito in Guatemala back on the list. So avoid the sticky lava flow due to the strong heat, which may cause burns and other serious injuries. I can't believe they have to say this on the website, but yeah, don't touch lava, folks. Don't touch lava. Also, don't get stuck in a pyroclastic flow. It's not a good way to go. Fuego in Guatemala exploding, flight level 170. Revenador in Ecuador exploding, flight level 150. 220 over Cotopaxi in Ecuador. As Cotopaxi explodes, Sabancaya volcanic ash not identifiable in satellite imagery, probably because it's cloudy, not because it's not erupting. And Villarica, Strombolian activity continues there. Again, please do not pole vault the caldera. Please do visit the links below the video. You'll find a link to our Redbubble shop. Our bestseller is Do Not Pole Vault the Caldera, and check it out. Seismic activity at very high levels here, having seen a 7+ magnitude quake. This is where it occurred. Near Indonesia. And it was at some depth. So that quake came in at 6:06 this morning on January 18th. It was at 48 kilometers estimated depth. And it was a 7 magnitude quake. And there was no indication of any tsunamis generated from that. Let's check the rest of the list here, as there were foreshocks. So we talk about it regularly on the channel, how any earthquake can be a foreshock. Even that 7 magnitude quake could be a foreshock. Let's hope it's not a foreshock to an 8 magnitude quake, as an 8 magnitude quake at the surface in that location could indeed generate a tsunami. So as far as what else has been shaken, a 5.1 at Tonga, a 5.1 at Papua New Guinea, and there's your 6.0 magnitude foreshock. 6.0 magnitude foreshock there. It's actually a bit to the southwest of that 7 magnitude quake. Malta also had a 5.0. Not super common for Malta there. Again, there's that 7.0 at 6:06 this morning. And of course, you can expect to see lots of foreshocks like this aftershocks like this 5.5. Also, the Turkey-Iran border region saw a 5.8 in the top 3 largest earthquakes in the past 24. And also the Mid-Indian Ridge had a 5.0 right in the middle of the northern Indian Ocean there. Let's get back to space, as there's a lot of carbon on the closest star. Check it out. That's 1,600 angstroms plus 335. And all those bright regions there, that is ionized carbon. Let us know in the comments where you think it's coming from. Is it just a bunch of dust in space that's just gathering on the surface of the sun? Or is it being produced there through nuclear fusion? Let us know what you think. That's the last 24 hours in ionized iron. That's the blue part. And ionized carbon, that's the yellowish-orange part. The 10.7 centimeter radio flux has dropped. We'll get to that in a minute. We did have an M-class flare just after midnight. As this area right here has got some serious magnetic fields. So this area right in here, very likely to produce massive flares. Also, we've got this huge filament to its south, named by Zach Toven on the Twitter channel. We'll talk about solar flares in more depth a little later in the video. There's a close-up in those wavelengths. That's 131 plus 171 angstroms. So yeah, the radio flux has actually dipped here. So now it's back down to 222 solar flux units. And for you new viewers, the radio flux is the most proportional data that we have to sunspot number. In other words, when sunspot number goes up, so does the radio flux. So you may see it here. We've reached new peaks here, reaching up to 234 solar flux units, the highest levels we've seen during solar cycle 25. Also, sunspot number has recently exceeded 200. And we've got a long way to go to get to solar maximum, folks. The magnetic field reversal process is barely getting started. Space Weather Enthusiast dashboard not forecasting any geomagnetic storms or geomagnetic unrest. We are expecting a coronal mass ejection impact here at any moment, actually. Although it may have arrived earlier. Maybe we miscalculated the speed, as we did see an impact late last night / early this morning. We'll get to it when we look at the real-time solar wind. First, let's take a look at Earth's magnetic moment. There is the geomagnetic planetary K index, an average of global geomagnetism. KP 3.33 is the current planetary K index, often referred to as the KP index. And here's Earth's magnetic moment from space for the past 4 hours. Things somewhat geomagnetically calm here. Again, we are expecting a CME impact, so don't be surprised to see this suddenly jump up to a KP4 or KP5 situation. Geomagnetic storm conditions could be around the corner. So, not usually incorrect that far in terms of the speed of the incoming solar plasma. We are expecting a CME impact as forecasted on the 15th. Anyway, that's the last 4 hours of Earth's magnetic moment from the ground. And looking at the real-time solar wind, we did see a CME impact last night. So right in here, you see a bunch of shifts happening all at once. So first of all, you see a huge increase in the magnetic field strength. Also a sharp dip into negative territory there. So that red line there, that's the BZ. That's the vertical component of the magnetic field as measured at Lagrange point 1. We also saw a shift in the phi angle, a shift in the solar wind density, and a shift in the solar wind speed. Also a little bit of a shift in the plasma temperature. So that was a CME impact. It has since subsided, apparently. Current conditions are Solar wind density about 13 protons per cubic centimeter. Solar wind speed 422 kilometers per second. And let's move on to magnetic data. So we had a huge shift there in the GOES magnetometers. That is a thing that you typically do see with incoming dense plasma. So that was a CME impact, and that is the signature of it on the GOES magnetometers from their geosynchronous orbits. And let's take a look at the heliospheric current sheet next. So at the moment, the entire North Pole portion of the sun is sort of directed at the Earth, South Pole portion mostly on the opposite side here. So most of the North Pole magnetism here is kind of oriented toward Earth. You can see the entire North Pole current sheet there, largely sort of oriented in your direction. If you're wondering where the data comes from, it's from 51 ground-based magnetometers and magnetometers on stereo A here at Lagrange 5 and stereo B here at Lagrange 4. Looking at the line of sight field plot, and we can expect to see lots of green lines in our vicinity. The blue lines there are the sun's B field. Green lines are north solar polar field. Red lines south. And let's move to coronal holes next, as we've got North Pole-oriented coronal holes here mixed in with lots of sunspots, especially in the northeast. So that's what's going on. The coronal holes that are visible now are all North Pole-oriented except one very important coronal hole that we shouldn't forget, folks. This one down here. Why? Because this is South Pole-oriented. So we've still got features of solar cycle 24 to 25 minimum showing up here. Also, this is North Pole. So we've got solar polar fields still here fixated at the solar polar regions. These are all North Pole-oriented coronal holes. The field reversal process is still years out. You're nowhere near solar maximum. So if you're frightened of high levels of solar activity, strap in. You can expect to be frightened for about 4 years. Anyway, let's move to sunspots next. And by the way, we greatly enjoyed yesterday's comments. Yesterday's comments were fantastic. We'll try to get to that later in the video. About the Earth's pole shift. A lot of YouTube channels telling people Earth's poles are going to flip and so on. Various aspects of nonsense that people take in on YouTube and accept as fact despite tons and tons of science refuting their nonsensical claims. So here's sunspots, and there are lots. So we'll have at least one new named group right here. Possibly two new named sunspot groups today. Also this group up here hasn't been named. So we may see 3 new named sunspot groups today and another big increase in the sunspot number. If you're hoping for no sunspots, I feel sorry for you because you are not getting your wish. Next, the SDO continuum imagery. You see some sunspots forming. We'll zoom in. So yeah, this group up here needs a name. I don't know why it doesn't have a name yet. This group here certainly needs a name. And there is also another group that just rose here, probably not so visible on the imagery. We will show you images of that later in the video. Sunspot activity. It's not shutting down. Where are your 0 sunspot days? Here we've added 94 angstroms. Solar cycle looking more and more normal as solar cycles go, as time goes on. Shout out to Scott McIntosh talking about Terminator events. We got to get him on the channel for an interview about this. And let's go to energetic particles and flares. So no spikes in the proton flux here. We did have a minor little event back on the 13th, but it was barely enough to even cause any sort of polar radio blackouts. Might not have even caused anything. And we've had a couple M-class flares here, including one that occurred while we did show prep. So 2 M-class intensifications in the past 24 hours, as noted by the GOES 16 and GOES 18 X-ray flux there. Remember, folks, you can't measure X-rays from the surface. They're filtered out by Earth's mesosphere. That's why we use spacecraft to measure the X-ray flux. So sometimes it's a little bit difficult to tell where a solar flare came from. One of the great ways you can do that is by using the SDO browse data. So if you bring up the browse data, this is yesterday plus today. If you press pause, you can kind of rock it back and forth, right? So if you know when the flare occurred, pretty easy, just before midnight, right, was that M-class flare. And if you're wondering where it came from, you can just move it ahead like this, and you see it came from this sunspot down here. The more recent one looks like it also came from that same sunspot group. So that particular sunspot group down there in the south, getting a little more active. Here's the last 24 hours in 94 angstroms, the same wavelength actually, just a little bit of a different saturation, brightness, and contrast settings there from SDO. For some reason, the browse data looks differently than the data on HelioViewer. And let's zoom in here. Once again, let me reiterate that these two sunspot regions are interacting across the equator. There are huge plasma bridges, and you can see them right in this area here, stretching across. And that creates an environment for very chaotic processes to take over. Don't be surprised to see a massive CME and or massive solar flares continue from those regions. Here's 131 angstroms. And you can actually see some plasma looking like it's flowing back and forth. Just splentacular imagery there from SDO. And once again, I would reiterate, we say it all the time on the channel, don't get solar flares and coronal mass ejections confused. Solar flares are X-ray photons. Coronal mass ejections are primarily hydrogen nuclei, aka protons. The difference between light and gas is very significant. Don't get them confused. Solar flares are light in the X-ray spectrum, photons. Coronal mass ejections are gas. The difference between light and wind are significant. Now, if you're up before dawn, you may see the crescent moon there, rising in the morning sky there near Antares. If you see a bright star near the moon, it's Antares. And that's what's going on over Lehigh Valley here. If you press now on this, by the way, it'll show you the current situation. This is just in the default setting here. It does show daylight as it is getting light here. That's skyandtelescope.org's star chart. And let's do a solar system forecast as we've got a crescent waning moon as new moon approaches. Here's your 1 week forecast for the solar system. There's where things will be in 7 days as Mercury moves to the completely unpopulated side of the solar system. Earth is following and Venus is catching up. We've got some missing data here from the George Mason University. No worries, we'll show the view from Stereo A and Soho Lasco C3 to show you the likely telemetry of the most recent coronal mass ejections. So we've paused this here at 1709 for Stereo A and 1706 for Soho Lasco C3 because we see a CME here. And for you new viewers, Earth would be off on this line from the perspective of Stereo A, which once again is located here at Lagrangian 0.5. We paused it there because that could be somewhat earthly directed. However, when we look at it on Soho Lasco C3, we can see that it's off to the northwest. You see that? That's the same plasma there. Now there's also another event happening kind of around the North Polar region right here. It's a coronal hole opening up before our very eyes. So check it out. You can actually see this void opening up here. That is a coronal hole. And that's super interesting because of the way it affects the plasma. Remember, folks, plasma orients itself to magnetic fields. It's not magic. Plasma is charged particles, and there's no shortage of that in space. as there's lots of ionizing radiation. Anyway, great image there of a coronal hole opening up and that CME. Also another CME event happening on the far side of the sun. And the point is, that is not earthly directed. There is no earthly directed ejecta there. It's just another cool light show. So let's let that play through briefly and then show you some 24-hour coronagraph videos. So expecting a CME to arrive today. Besides that, it's pretty clear in between Earth and Sun. There's the last 24-hour in composite. There's a little zoom out. And we'll zoom out further. And let's talk about filaments next. We've been naming them on Twitter. And wow, our Twitter followers are all the way up to over 360. Oh my God. It's amazing. Somebody will actually see the content, perhaps. So here is the Cerro Tololo ground-based solar observatory. And look at the size of these filaments. Dag. Massive number of filaments here, and some of them very huge. This one at the equator looking like it's becoming unstable right now. And I think, correct me if I'm wrong, I think that's the Dick Van Dyke filament. Dick Van Dyke filament looking like it's fixing to launch. Anyway, if you've got a filament you'd like to name, we invite you to the Twitter feed to, of course, name that filament. Thanks to everybody who's named filaments. We name them after living people only because, well, it's because reasons. Anyway, here's the last 24 hours in ionized helium, the SDO 304 angstrom spectacular wavelength. Note the fine detail and narrow field of view. Next, note the less detail and wider field of view of the GOES 16 SUVI. That's part of the reason why we stream it all day on the Twitch channel at twitch.tv/smashomash. And yeah, it's great at showing coronal mass ejections as they happen. Also, prominences show up great in the GOES 16 SUVI 304 angstroms wavelength. That's the last about 2.5 hours. And let's move to our bonus features segment, where we'll talk about things like satellite charging hazards. We have some minor charging hazards here over the Eastern Pacific. Also, Central America, Mexico, and moving into the Central Pacific. Some minor charging hazards there on the surfaces of satellites caused by low-energy electrons. Speaking of electrons, there is your GOES electron flux coming up off the floor here a little bit. And we can expect to see this kind of all over the place today, especially if we do have a coronal mass ejection impact as forecast. Next, the forecast model. NOAA expecting a little dip in the electron flux. And if we see a major impact, we could expect a more significant dip in the electron flux. In any case, that's the NOAA forecast model. No arguments there. Here's the one-year chart to put the relativistic electrons in context. We're just in a normal, moderate operating range here. Pretty unremarkable there. Let's take a look at the F layer of the ionosphere where the electron flux is measured, which is certainly quite remarkable. So the F layer is located at about 300 kilometers of altitude. Here's the vibrational frequency of that bridge between Earth and space, which we've been noting massive anomalies here on the channel for probably over a month now, since the South Atlantic anomaly has moved into the South Pacific and the South African anomaly has moved to the north. Which brings me to interesting facts. So lots of channels out there telling you Earth's magnetic poles are going to reverse. We're telling you we don't believe it for a second. And there's all kinds of reasons to not believe it, which we won't get into in this video. It is the daily space weather video. Although we do have an in-depth video on our playlist the diamond anvil too hard to smash, where we talk about Earth's geomagnetic field, Earth's geomagnetism versus Earth's magnetism, the magnetic pole versus the geomagnetic pole, and so on. Anyway, so that's what's going on, and it's highly anomalous. If you're not used to looking at this imagery, that's okay. We'll show the anomalygram as well. So here is your anomalygram, and we've got wild swings here. We've got global high-frequency anomalies happening, and then huge low-frequency anomalies happening at the North Pole, and then rapid swings. So the ionosphere is all over the place for the past month plus. And apparently we're the only channel that notices this. I guess because we're the only channel that immerses ourselves in facts about space weather. Not exactly sure where everybody else is on this, but whatever. Those are the facts. We're stating them. We don't intend to stop. So let's bring up the latest image. Massive anomalies happening there. And there's the latest. That's 11:45 Universal Time. You can see high-frequency anomalies all over the planet. Next, we'll show the total electron content forecast because we've been seeing ridiculous GPS errors. The most GPS errors we've ever covered on the channel in the past about month. And check this out. Here is your total electron content. And expect GPS errors wherever you are. Turn on your Wi-Fi location accuracy. We've got huge and bizarre total electron contents. I mean, look at these bands down here where we've got low electron flux just mixed in. That is out of the ordinary for sure. So we'll let that play through one more time here. The total electron content shows the free electrons between your GPS satellite at about 12,500 miles of altitude on your handset. It's a coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And that is highly anomalous. Last but not least, when we close out our space weather section, we're going to show you the high-res imagery here. And of course, we've got some new sunspots up here in the northeast, so let's check them out. So 2 new sunspots up there. This group definitely needs a name. This group likely to get a name also. It looks quite solid. Also, this group up here deserves a name. So we may have 3 new named sunspot groups today. The fields of these groups right here remain quite magnetically complex. And, keep in mind, folks, that if these sunspots were by themselves, they might have magnetic loops that look like this. However, I think their magnetic fields are overlapping each other, which could indeed make their magnetic fields look like this, to the point where they're off the SDO's field of view. And the interaction between these 2 sunspot groups is certainly sufficient to be associated with major flares, as we've seen this happening throughout its rotation here. There is a plasma bridge in between those 2 sunspot groups. They are both very massive, and they are both beta gamma delta class sunspot groups. So by themselves, they're very likely to flare, and we believe that plasma bridge makes them even more likely to flare. Them's the facts. We're sticking to them. We will not mislead you for any reason on the channel. And we'll talk about yesterday's comments. Anyway, if you want to support the channel, consider doing so by becoming a patron, perhaps. You can easily support us via a Patreon membership. We are still on there, although we've replaced it with our own subscription services site. If you haven't checked that out, smashomash.com. You can find links below the video to all of that. Smashomash.com/SmashTeam is our own subscription services site. We launched it in October of 2021. The best value is the gold annual paid-up subscription. That includes complimentary merch, by the way. You can get some Smash Team merch in the form of a hat, a scoop neck shirt, or a unisex t-shirt. We got you covered. Also coming out with additional content that only our Smash Team members will see. Click posts to see our latest videos. We also send out email alerts for things like disasters. Thanks to the Smash Team, especially gold and silver, there's also a bronze membership, which doesn't require you to open up your cobweb-encrusted wallet and send us anything. And welcome to the Neo Renaissance. You can find our homepage below the video as well, smashomash.com. Help us out with clicks. Visit us on social media. Let us know in the comments what your favorite social media account is. If you've got imagery you'd like us to show on the channel or something like that, hit us up on Twitter, Facebook, etc. We've also got a Discord chat. You can find the permanent link on the homepage, smashomash.com. We are writing a paper to explain the mechanism underlying the solar sunspot cycles. You can also find links to our merch below the video, which will link you to the Redbubble shop in order of best selling. So don't pole vault the caldera. Our finest days lie ahead. If you think the U.S. is collapsing, well, where are you going to go? Where are you going to hide, okay? The U.S. dollar might be inflated, but the euro, the yen, the yuan, etc. are all inflated much worse. So you're not going to hide in the eurozone, and you're not going to get away with fraud if I have anything to say about it. So the line between fraud and misrepresentation is literally intent, folks. It's literally intent. This is today's featured product, by the way. Are you accountable? A lot of hacks on YouTube aren't accountable and are making 6 figures to 7 figures to spout and shovel a bunch of nonsense onto your screens. So, with respect to this particular public figure, I realize that he is a fraudster in December of 2020. Again, the line between misrepresentation and fraud is simply intent. Misrepresentation is misrepresenting material facts. Fraud is intentionally misrepresenting material facts. You know anybody like that? Press like, subscribe, and share if you enjoy the content on YouTube, and thanks to our YouTube audience for tolerating the pathetic and putrid censorship on the platform. Yeah, we got playlists. We got playlists talking about Earth's geomagnetism. And let's talk about yesterday's comments. So we got some fascinating comments yesterday talking about a channel called Maverick Star, which is allegedly measuring Earth's magnetic fields. And apparently the purveyor of that channel, the I don't know what he's called, Maverick Star, whatever he's called, is now claiming that Earth's north magnetic field is moving back toward the north geographic pole, and he's very concerned about it. And I would be concerned about it too if my grift was based on a magnetic reversal. So magnetic excursions end with the magnetic fields returning to their normal location. That is the most common thing that happens. It happens all the time. And yeah, if that's what's going on, you could be seeing an end to the magnetic excursion. And if you're seeing an end to the magnetic excursion, you're going to see the end to a lot of grifts on YouTube. So you may just want to be aware of that, because we don't believe Earth's magnetic poles are in the process of reversing. And there are certain hack frauds out there who are trying to convince you or subtly suggest that Earth's magnetic poles are reversing, when in fact they're not. Moving on to our meteorology segment. And we're looking at one of Null School's many layers. So this is the space layer, and there may have been some great auroras there in Alaska. Even still, there may be some aurorae happening in Alaska. And as far as the southern aurora australis, perhaps visible there at New Zealand, but kind of unlikely. And we just like to highlight the various features of nullschool.net's fantastic maps. And of course, you can even display the map in weird ways, like, oh, how about this projection? Oh my God, that proves that the Earth is croissant-shaped, right? No, the Earth is football-shaped, you idiot. Welcome to Pigskin Earth. God, so dumb. Everybody knows Earth is shaped like a croissant, okay? All right, here are the surface winds of the eastern world as we blast through meteorology. These are the jets of the east. Looks like clear skies over northern Australia there, as there is a counterclockwise rotating upper-level high-pressure system. Kind of like Jupiter's Great Red Spot, only much lower pressure. Next, the western world's jets. Tripled up jet stream over the Pacific Ocean, and a divergence of the jets over the Atlantic Ocean. Also a high-pressure upper-level system there over the Azores, which are on my bucket list. Next, surface winds. Surface winds of the central world. Shout out to our viewers from all around the planet. jet streams of the central world are looking like this. And let's get through a whole lot more information here. This is clouds and fog over the Americas. 3.9 nanometer radiation satellite projecting the croissant-shaped Earth onto a spherical fake NASA Photoshop template. That's what's going on in terms of clouds and fog over croissant Earth. Here's our weather.gov map. And we'll scroll down so you can see the key. If your area is lit, click your area. Those light pink areas, those are winter storm warnings. And we'll show you some forecasts next. So here's pressure and precipitation based on the GFS model for the next 3 days, or 72 hours if you prefer. As we have this low, it's going to move up toward Lake Superior and then make a right to the east, according to the GFS model. Skimming right across the Great Lakes. And bringing some heavy snow to Nebraska. Let's see how that plays out. Here is your GFS 72-hour positive accumulated snow depth change in inches forecast. Expecting about a foot of snow in central Nebraska. Also California. California getting some additional snow there. As if it didn't have enough. Must be some great alpine riding conditions. Next, we'll also show temperature anomaly forecast. Keep in mind that's degrees Celsius. It is the same model. That is the GFS 72-hour temperature anomaly forecast in degrees Celsius at the surface. And some warm days here for the Northeast. And most of the eastern portion of the country, for that matter. And we've got another forecast to show you here. Here's the snow accumulation forecast based on the European model. We showed you the GFS. Zoom in slightly here to show 48 states of AUSA, the allegedly United States of America. There we go. That's pretty good. And so there's the next 12 hours of expected accumulation, mostly in Colorado, but making it into Nebraska. There is the next 24 hours. Expect some heavy snow in the next day in Nebraska, especially also Iowa. And there is the next 3 days. By then, lots of snow striking the U.S. Next, our NASA Goes Lightning Mapper, and we did have a thunderstorm in Oklahoma, Arkansas, and Missouri. Do we have any terrestrial strikes at the moment? We did have some between Memphis and Tulsa. Looks like things are calming down there. That is a real-time lightning map, by the way, from lightningmaps.org. If you've never seen it, it's in my favorites, because when I hear thunder, I break out lightningmaps.org. Did you know that a severe thunderstorm is one of the only things that'll cancel a bicycle race? Yeah, typically not even snow cancels a bicycle race, but severe thunderstorms do. We don't like riding in severe thunderstorms. Anyway, all right, we do have activity happening here, right around the Arkansas-Missouri border. There is thunder rolling in on the set of Ozark. Wait, there is no set of Ozark. The show's over, I think. Is the show over? I can't remember. Was the ending stupid? I can't remember either. It's like Breaking Bad Junior wannabe. Anyway, that's your lightning map. And let's check out U.S. Doppler radar. Got a lot of moisture there in the central part of the U.S., also the Northeast and the Northwest. We'll focus on the lower 48. There is your clouds and fog view. It's too dark over most of the country to use the visible satellite, so we use the 3.9 nanometer radiation map. And there is water vapor. We do have this dry mass of air here, kind of making a little bit of an impulse to the northeast. But it's pretty weak because there's a relative low here behind it, so it's not really moving to the east very well. It's kind of just hanging out there. Keep in mind the Rockies do slow the winds down and they cause a pressure gradient to happen there due to winds that primarily blow in this direction. You get an effective high pressure on the windward side and a low pressure on the leeward side. Anyway, here's where we'll close things out. That is the U.S. Doppler radar map showing vertical motion of water droplets and ice crystals. There is the 3.9 nanometer radiation satellite showing clouds and fog. And there is the water vapor map showing all of the water vapor. And that is where we'll close things out. Thanks for tuning into the facts expressed on the Smash News Network, least busted name in news. Congratulations on realizing the channel exists despite the pathetic, putrid, ridiculous, and nonsensical censorship of facts by certain criminal organizations. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and not misleading investors. From the Smash News Network, least busted name in news, may that solar wind be at your back, and that fraud absent from your YouTube subscription feed. Facts stated in this video suppressed for your convenience by big tech organizations. Opinions expressed in this video not necessarily the opinions of Smash News Network, least busted name in news.